And today I'm going to talk about using Vivado. I don't know if that's the correct pronunciation or not. It's just what I have always used. The pronunciation I've always used is Vivado for programming Xilinx, and we are going to here also see how to load it onto the board. So the first thing, of course, to do is to start it. And has yours finished installing?
It's like a few seconds, but it won't actually install all the way.
What's it the hang up?
Well, it's still downloading all the files before installing it, so it's still going to take quite some time, I anticipate.
Oh, I thought you had already done that part. No, that's the part that takes forever.
Oh,
Yeah. So you need to use this computer. Yep.
okay.
Okay. So the computer I am demoing on, but I don't think I'm sharing my screen yet. Let me share my screen. Oh, but there was it. You had something in chat. Hold on.
Oh yeah, do we sign in like we did last time?
Let's see. What is today? Yes, we do sign in. Thank you. Let me get that. Let me first see what I'm. Screen one. Okay, so am I sharing my screen?
Yes.
And you don't see yourself in the screen. You see a ABA thing.
Yes.
Yeah. Okay. All right. So let me get my sign in. Hold on. Today is 11/12, but this is not EE 2120, is it? No. Okay, so no, I do not have a sign-in. I need to remember who it was here, but I can remember that, and I can turn that in. Okay. If you help me remember before you leave to just turn that in, that would be useful. How's it doing?
It's a fifth of the way installed.
Okay, all right. Okay, so I am going to go ahead and get started because I do have to do some other stuff.
Real quick, is there a specific version to download?
Are you trying to download it? It takes hours, by the way, especially if you're not on the LSU network. If you want to find the instructions for downloading it, I have, let me show you where to have it, because yes, there is a specific version. Let me show you where that is.
Okay.
So let me go to see if I put it in my instructions. So if you go to SI Resources and Verilog Editor, maybe. Let's see what that has to say.
Isn't installing Vivado?
Yeah, it is Vivado, but it is there. Okay, so it was. You don't want Greek, you don't want Spanish. Okay, so I don't have the instructions here, but I do have a video where I show, it's not a long video, but it has, it shows like what the various different options are that you want. So it's 8 minutes, and so you just kind of go through it.
Google Xilinx.
So let's see.
Okay.
Yeah, so you have to make an account, and then anyway, it all says in here what all you want. And so if you just go through that, it'll tell you. You won't have time to do it right now because it does take quite some time to download, but it gives
Okay.
you. It does tell you there. So also for anyone else watching this video later, that's where to find the instructions. And if I get a chance, I thought I wrote them up somewhere. I do have them written somewhere. I'll see if I can find them. Where did I put it? Maybe it's in the other class. Nope. It's the same. Okay, so I have them written up, but it's in the context of installing VirtualBox on a Mac, and it has like the individual steps on that. But I will get those written up as well. But it's all in the video. But for right now, we'll just James, you can watch, and Ryan, you can play along on that. Okay, so when you install or when you write a Verilog program, there are two main parts, two and a half main parts that you're going to do. Oh, hi, we have someone else. Yay. Okay, so I was just getting started after having done some preliminary stuff. So when you write, so are you interested in seeing how to write the Verilog and how to compile it and all that? I'm sorry, say that again? Okay. Okay, so when you start Vivado, you want to just create a project, and you'll go to next. Oh, I was saying there are two main parts. So you have your actual Verilog code, and then you have your constraints that tell you what the variables are on your actual board. So you are constraining the variables to the hardware. So you'll give it a name. So I will call this, I'm going to call mine November 12. And it's going to be an RTL project. And your package, well, your family is going to be Artix-7. And the package is the second one, CPG238. Your speed is -1. And
Gotta search for it.
no, there should be, usually there's 3 of them, and it's the second one, so I don't know what, am I misremembering something?
Okay, I found it.
Which,
There's someone right here.
it's 236.
Okay, this is the from the.
It's 236, yeah, that's it.
No, I
It's
think-
236, not 238, and then it's the middle one right there. Yeah. So 236, and then it's the middle one. That's the one that I always do. And then next, and then finish. and then you'll get to this screen, and we're going to start by putting in design source. This is our actual Verilog, and so I don't know if I'm doing it the same way the lab manual does or not, but I click on design source and I click on plus for add sources, and then add or create design sources, and then I'm going to do create file, and I'll give it a name. I'll just call it, I can call this one November 12 as well, and then finish. And then you can, at this point, if you want, put in some of your inputs and outputs. I usually don't. I usually just at this point go ahead and just say okay, because I want to type them in myself, and then I'll say yes. And then your code will be there, and it'll be a .v under design sources. Then double click on that, and it'll have filled in at the top the time scale. It actually works without that, but you can leave that in there, and then just some stuff that's commented out, and it just will have the name of the module and end module. And it does have the open parentheses and close parentheses, and here let's put in, I'm going to do something slightly different than what y'all are going to do in lab. So I will have, I don't know, what do we want to do? Let's have, I'm just making stuff up. Let's do A, B, C, D, and E. Sounds, let's make one of these a vectored thing. So, well, we don't have to do it here. Let's do A, B, C, and D. And then I will have input A semicolon and enter, and input. Let's see, how does this work? I can pull up another one, make sure I get my syntax right. Input, okay. So I'll do input 1:0 in square brackets, B semicolon, output (1:0) C semicolon, and I think that's all I want to do today, so I'll take D out of my input-output list. Now, let's see, what would we like to do? Let's have, what are y'all doing in the lab?
I give some sample code it wants us to type out, and it gives a few ways of doing it, and then it moves on to the constraints.
Okay, so let's do an always block. Yep, let's do an always block. So let's do always at A, comma B. And let's do an if A, I'm just going to do if A, so that means if A is 1, so we're going to do this like a multiplexer, so A is going to be a multiplexer, so if A C C1 or C0 equals B0 and B1, semicolon, else, no, and let's make C1, we need to make C1 equal to something too. So if A begin, oh, I need to make C a reg because it's inside an always block, so I'll have reg output, or this is an output reg. Output reg, yeah, output reg. Because I'm assigning it inside an always block. And then let's make C1 equal to B0 or B1. And then else, I need to end that block right there. Else, what would y'all like to do? Else, okay, let's just show you how this works. Else C equals B, semicolon. Okay, so we're assigning both of them at once. All right, so we did our, that is our code, and you can save it, and then it's time to do our constraints. So this is the part that's going to be new. So the easiest thing to do is to get,
I'm just following along.
okay, is to get a template file, which I don't know if I have put up in the class yet or not. It's available in other places, but let me make sure that it's also available from me. So let's get that. So it's now available there in the SI resources. So it is just a template file. It has all the possible constraints that you might want. And they're all commented out. So I'll just copy those and uncopy the ones that I need. So I'll go to constraints. I'll click on constraints in the sources and then click on plus. And I'll do add or create constraints, and I'll do create file, and I'm going to call this November 12 constraints, and OK, and finish. And then under constraints it'll show up, and I can double click on it. And I will, oh, wait a minute, I put the wrong constraints file in there, the wrong template. Did you get my template, or did you get?
I did. Check in the SI resources.
Yeah, I put the wrong one in there, hold on.
What are constraints?
Okay, so constraints are where you're telling it what variables map to what parts of the board, and it won't make a whole lot of sense until you see how it works. And so it will make sense in a minute. So, but right now it probably doesn't make any sense. Anything that is an input or an output is going to have a constraint associated with it, because inputs and outputs show up. They're actually things that you have to do. Anything else, like that's a wire, for instance, you would not have a constraint for, because that's something internal. So again, I know that doesn't quite make sense yet, but it will get there. There it is. That's the one. So basis 3 constraints. Okay, so right now they're all commented out. So I'm going to show on my screen and go through and like explain what's going on here. So the top part says the very first thing in there is the clock signal. You'll see when you get to using the clock, you're usually going to replace this with not the actual clock, although you can use the actual clock, but this you'll usually replace it with a button that will just represent, a clock cycle. But we're not going to use that. The switches, these are the switches on the basis board. So if I am on Zoom, let's see, so let me instead show you a picture. So y'all have not used this board at all yet, right?
No.
Okay, so let me explain what we have. So this is the board. And it has running across the bottom a number of switches. Let's see, 1, 2, 3, I don't know, however many switches it has. And if you look underneath each switch, it has a little number and letter. So like the one on the far left is, you can't read it on this screen, but it is R2, and the one on the far right is V17. And those are the switches, and when they're down, they're 0, and when they're up, they're 1. And if you look at the constraints file, it shows, if you look at the very first constraint, it has pin V17, and that's the one on the far right. And then V16, and then W16, and these are the names of those different switches. So if we want to associate a variable with one of these switches, then we're going to put the variable's name in here in the constraints, and I'll show you how to do that in a minute, and we will uncomment it. So this first section is all for the switches. The second section is all for the LEDs. So the switches are going to be inputs. The LEDs are going to be outputs. And if you look at the basis board, right above the switches, there's a series of LEDs. And if you look at the LEDs, next to each LED is also a number that is going to be associated with it in the constraints. And again, it's going to go right to left. And so when we look at the constraints, the first one is U16, and U16 is the one on the far right. When you actually look at the board, let's see if there's a better picture than that. Yeah. So when you actually look at the board, it looks clear when I zoom in like that. You can see the difference between the U's and the V's, but with my eyes, I have a hard time telling the difference between the U's and the V's just looking at it straight up. But you can see it here, and this is just the basis manual. I don't know if you have a link to the basis manual in the course, but it's easy to find online. So those are the LEDs, and then those are the ones that we're going to use today. But the other things that you have are the 7-segment display, which I think you use later this year. You might not use it this year, but the 7-segment display, that's these the digits that you can make. You can set them up to be numbers or letters. That's the decimal point. That's also part of the 7-segment display. What's right underneath that, these ones that are AN, that's also part of the 7-segment display. Then you have the buttons, and the buttons are the part right here in the middle. You can use those, and those are the only ones that we're going to use. So the rest of these you're not going to use. Nope, none of those we're going to use. So you can take those out if you want, so that they're not distracting. I'll just delete all of it for this project.
To work on my laptop.
Excellent. Okay, so how far?
How do you mean?
But you don't have anything on it yet, do you?
No.
Okay. It shouldn't take you long to get set up.
Yeah.
Let's see. So I'll just keep talking. You'll be able to catch up.
Mm-hmm.
Okay. All right. So now let's go to those constraints, and now we have to tell it what we want each of our things to be. So we had in our program, we had our inputs were A and B was a vectored signal, and so I'll check something real quick. I never use and or. Is single ampersand and a single vertical line?
Yeah, it says for an or page there's a single vertical
Okay,
line.
all right.
Is this supposed to be the and?
That's an exclusive or.
Oh, okay. Then the and is just a single.
Yeah, single ampersand. So that's a bitwise and an or. I think a logical and. So a logical and, like if this and that, is a double ampersand, and a logical or is the double vertical line.
Okay.
Okay. So so what we'll do is we'll map a switch to A. So because I can't keep track of where anything is, I'm going to map pin V17. So I'm going to take out, you can either leave the curly brackets or take them out, it doesn't matter. But for V17, I'm going to change this SW0 to A. And then you want to think about how you want your B to be set up. So we have B0 and B1, and so you want to decide if you want 0 or 1 to be on the right or the left. And so I'll have 1 be on the left and 0 on the right. So I'm going to make pin V16 B0, and I'm going to make W16 B1. and then I'm going to uncomment those lines, and I can do that quickly by highlighting those lines, and then there's a little toggle up above in the menu bar to toggle back and forth between commented and uncommented. I find I make the most mistakes in the constraints, and when it goes to compile and I get an error, that's going to be where I make my mistake. Okay, so now I want to set my output, and I'm going to have them be on, I want them to be above the B switches, so I will have them be E19 and U19, and I will make those C0 and C1. As I do more and more programming with Verilog, I get more and more lazy, and I call my variables either like SW or LED or seg for segment. I just use the same ones that are in here, so I don't even have to change the names. So I can just, like, uncomment them. But so now I will uncomment these. Whoops, I did that wrong. I was trying to talk and type at the same time. All right, so I think I have that, and I have that. And the first thing you can do to check to see if it works is to do open elaborated design, and that will tell you what it thinks, it'll map it to hardware, so it'll show you what kind of hardware it thinks you meant. And this will sometimes, you can catch like a big logical error here if it doesn't look like what you think it should look like. Oh, I would say mine looks pretty beautiful. Does that look like it's doing what it's supposed to be doing, or what?
It looks nice.
Yeah, so we got the multiplexer for the A. I got an AND gate and an OR gate. And yeah, that looks perfect. That does not mean it will compile. You can get to this step. Oh, sweet. Okay, so it does not mean it'll compile. Everything can look good here, and then it might not compile at this step. So the next step after this is to generate bitstream, and I do not know why it takes so long to do this. You'd think in this day and age it would not take this long, but I'll click on generate bitstream and I'll say yes, and just okay, and then you can keep an eye on the top right of the screen, and it'll tell you what's going on. So running synth design, and eventually it'll either come back and it'll say, the bitstream is okay, or you'll get an error, and it'll be like the error will not tell you anything about what's going on, because that's the way errors work. So now we just have to wait. So I'm going to pause the video.